All right, let's get this thing started. Hello, everyone. Hope you are okay and doing well. Sorry about the small delay there. I delayed a little bit more than I wanted to delay, but I literally got a call from Park, the course supervisor. So I tried one last time to kind of get any information out of him that I could. So yeah, I just hung up with him just like a few seconds ago. Because I did want to verify some things moving forward, so I don't want to speak out of turn today. So we do have a couple things that I want to get out of the way, and I don't know, should I write some of this down maybe, and maybe not. Okay. Yeah, remember I told you guys I'd get those blue light blocking glasses, so these are some of them. And so I'm running this experiment, and so far I think they're going okay. I think they're going well. I got two. There's another one with like a thick lens. I don't know. I like this one more. But yeah. So yeah, I think they actually help, just in case you're wondering if it's all snake oil. I think they help. But yes, okay, moving on, getting in on target, because I know it's an extra class, so I don't want to waste any time. Let's jump right into it. So regarding the emails that I sent you guys about the Zoom and all that stuff during proctoring. So yeah, there's not going to be proctoring in the traditional sense. It's just that if you have a question or an issue, we have to have these rooms open so that you can actually find me. So if you have an issue while taking the exam, you can go in and you can find me either at that Blackboard Collaborate Ultra address, or if for some reason that's kind of messed up, I will have the Zoom room open. So it's not that you have to like log into Zoom or log into Blackboard Collaborate Ultra specifically. You just need, that's where you'll find me. So I'll open a room in Blackboard Collaborate Ultra during the exam, and you'll know where to find me there. So that's what, so there's no proctoring into the traditional sense. And to answer Kevin's question, was that Kevin's question? Yeah, so pretty much I just have to hang out, and I want you to know where to find me. It'll probably be quickest to find me at one of these points. Yeah. No, just go straight to the exam. You only open Blackboard Collaborate Ultra if you need to ask me a question, if you need to get in contact with me. Yeah. So you go into the exam the same way that I showed you guys last time, the same way that I had you guys try out while online. And so, yeah. So yeah, I was telling some people, because I thought it was more traditional proctoring, but nah, they're like, forget about it. So technically you won't need a camera or audio or anything like that, just be able to type and send me messages, or at least the best way you can, the best way you'd want to. Just make sure that you can actually ask me a question if you need to ask me a question. Okay, David just came in. So yeah, so yeah, so regarding Blackboard and Zoom, I will have both. Yeah, so I will have both. The default should be Blackboard Collaborate Ultra. Okay. So, and I'll make a note. I'll be sending out emails to you guys to let you know some procedures. Default is Blackboard Collaborate Ultra. If for some reason that's not working, and I have very little faith in Blackboard, as you guys know, then you have the link to find me in Zoom. Also, just as always, as I expected, try to make sure that Your question should be saved automatically once you move on, but just to make sure, look in the top, I believe it's top left or top right. I'll also put that in the email. I have a list of things I want to send you guys in an email to look out for during the exam, but to make sure that your problems are saving correctly. Apparently a few students have been having issues where their answers weren't saving. They moved on, they thought they answered it, but somehow it didn't get registered. I don't know. But apparently the glitch is if they're moving too fast or something, I don't know. But yeah. So just in case things aren't working, that's what those guys are. I'll put this all in an email. They're moving too fast in math. Yeah, the thing couldn't keep up. What else regarding that? So the exam is 25 problems. It's going to be even number of points each. So 25 problems. And so you'd have 4 points each. And I was told that proportionally, they kind of want to keep the same proportion of problems as you would have in a paper exam. So if you look at the past finals, which I referred some of you guys to in a final exam review, yeah. Okay, so I have a lot of people just coming in right now. It's like making me lose focus here. Okay, so final exam on Blackboard. During that exam, I will be in Blackboard Collaborate Ultra and Zoom in case you need to reach me. The exam will have 25 problems confirmed. I literally confirmed it on the phone just a minute before I came on here, and even weight each problem. So you just go through, and also proportionately, it should look similar to a paper exam. And he maintains that if you would have been good on a paper exam, you would be good on a multiple choice exam. We are going to practice some problems today as well, but just so you know, if you've been preparing for a regular paper exam, you should be okay for this exam here. And yeah, so maybe I should get these things started here. Okay, there we go. Oh, you're done with physics? How was it? There we go. So maybe I should make a note of some things, important notes. So boom, I will be available in DB Ultra and Zoom during the exam for questions. Two, exam has 25 problems, 4 points each. Ensure your answer is saved before moving on. And up to yesterday, I still had people asking me when the final is. So again, the final is Thursday, May 21st at 3:30 p.m. to 5:45 p.m. is the date. Let's see, anything else I want to mention right away? I don't think so. If you're ready for a paper exam, it should be fine. We'll practice multiple choice though. And that being said, I posted final exam review problems. Posted a bunch of problems. We'll discuss later. Let's see. Let's see. Anything else I want to mention? Okay. My classes. So I might have people joining today from other classes, but something I do want to mention, my classes are over prepared. We'll discuss later. We'll probably start off the discussion talking about that. And I'll come back up here and enter any important notes as they came up. Okay. Okay. So yeah, let's actually just jump into it. We've been kind of dilly-dallying for a while here, but I still have stragglers coming in, and every time I hear a sound, every time someone enters the room, and I keep getting knocked off my train of thought. Let's actually just focus up and get to this. Okay, so important notes, nothing much new. We just verified that there are going to be 25 problems. Again, you have 2 hours and 15 minutes. That should be straight. Oh, something else I do want to make sure to mention, whoever is here who might not have talked about, if you have exam accommodations, that's 2 M's. So I don't have many people, but if you are entitled to exam accommodations such as extra time or any of that things, and you're registered to the accessibilities office, you need to reach out to me ASAP, because we need to set up your final. Especially, we need to go in and make sure that you have the extra time or whatever accommodations you're entitled to. So yes, be sure to do that. Okay, now let's talk about point. Before we move on, let's talk about point 7. Okay, so like I mentioned to you guys, when I was teaching the class, I went deeper and wider than we had to go a lot of the times. And so what I don't want you to do is spend time studying things that you won't necessarily need to know. Even though I do believe they're important, I believe it is for the worst that these things were left out of the syllabus, so that's why I taught them anyway. So if you're in my classes, we covered everything that all the other classes covered and more. So you guys are, not only do you know things deeper than the other classes would have known them, but you also know extra stuff that the other classes won't have known. So you have the potential of going off the rails studying here, which is why I put up the practice problems from the final. If you don't really see a problem type on one of those practice problems that I mentioned, chances are you can ignore it. So there are some things that I want you to ignore for the better part. My classes should ignore the following. Let's see, I made a list here. Yeah, 1, in integration techniques, Weierstrass substitution. Don't need to know it. Very cool, but you're not going to be tested on that. Ignore Weierstrass substitution. Another thing, calculus of parametric equations, ignore them. So when it comes to parametric equations, I know we're in a calculus class, but technically the calculus of parametric equations is not something that is like officially in the syllabus. What you do need to know is know what they are and how to, you should know how to graph them or how to match up a graph, know how to get a graph, find points, eliminate parameters. But of course, when I say calculus, I mean finding derivatives. You do not need to know how to find dy dx for a parametric curve. You do not need to know how to find tangent lines for a parametric curve. You do not need to know how to find arc length for a parametric curve. Okay, so we covered this, but you don't need to know it. You will need to know it eventually, and you'll definitely have a leg up on anyone who does not know it for sure, but it's not in our syllabus, so I don't want you guys to do it. Parametric equations, yeah. Now polar coordinates are covered under here. So for polar, I didn't really teach anything that was not necessary for polar, I don't think. Polar coordinates, no everything I taught. I didn't go off on this. And that's because polar coordinates, other than what I showed you guys, isn't used ever again. Like it's something that's really cool when you do it in Calc 2, but you never see it again. Like I've never seen anyone draw a polar curve outside of a Calc 2 class. It's like it never comes up. So even though it would have been nice to do graphing and some other stuff, I decided to not go deeper with polar curves because it doesn't really show up. You need it for cylindrical coordinates that you'll see in the next class, but you know enough to actually do that. So we don't need that. What else? So in particular, you need to know how to convert between polar, know how to convert between polar and rectangular coordinates. We'll do some problems like that today. Know how to convert equations. So if you're given a rectangular coordinate equation, you should be able to convert it to a polar coordinate equation and vice versa. So, I mean, this is kind of falling outside the list. So this is something to know, not ignore. So, these are things to know here. But calculus, ignore. When it comes to polar coordinates, ignore the calculus part, even though we're in a calculus class. Yeah, the Pythagorean identity. You get a lot out of that Pythagorean identity. Yeah, you can derive a lot of things. Like almost all of trig comes from that identity. Let's see here. But you can think of trig as an application of parametric equations, actually. So if you think of x as a cosine function independently, and you think of the y as a sine function independently, then you get trigonometry, everything out of trigonometry, just by taking those two equations to their logical conclusion. Let's see here. What else? Yeah, another thing to ignore. I don't know, maybe I should have left that in red. Ignore error estimates for Simpsons and trapezoids. You do need to know how to estimate the error that you get from a series approximation to an integral. You don't need to know about error estimates for Simpson's rule and trapezoid rule. What else should you ignore? Applications of Taylor series. I gave you a bunch of them. I gave you like 5 applications of Taylor series. Except there's one that you should know. So you should know how to use series to evaluate integrals. So all that other cool stuff I told you about Euler's equation, the binomial theorem, and all these applications to number theory. If you we have some more people trickling in here. If you actually know, there's going to come a point in your math journey where you're going to go into a class and they're just going to start talking about these things like they expect you to know them, but there's no class before that where they're actually taught. So yeah, I taught you guys those things. So now you know it when it's going to pop up. So a bunch of those are going to pop up in 391 without warning. Just like how complex numbers pops up in 391 without warning, there's no class lower than 391 at City College that goes into complex numbers. But you get to a point where eventually everyone just kind of expects you to know about complex numbers for whatever reason, right? So there are a lot of things like that, and some of them I touched on. Okay, what else? You can ignore the remainders theorem. That's the one that will kind of tell you how to know that your Taylor series actually converges to the function that it's describing. So, and there's one thing that's quite the opposite. So there's an opposite topic. So it's not in the syllabus, but you should know it. And that was our little journey into conic sections. So you should know about hyperbolas and know about cones and know about, well, cones is the 3D, some 3D versions, but you should know about how to draw a hyperbola, an ellipse, a circle, all that good stuff. You guys saw that came in handy when you were sketching quadric surfaces and doing traces and all that stuff. Other things you can ignore, let's see, derivations of dot and cross products. Okay, so I kind of explained to you where these guys came from. You don't need to know that. Just know the definitions. So just know what a dot product is, know what a cross product is, know how to find the angle between two vectors. You can do that using a cross product. Know that the dot product of two vectors is 0, means that they're orthogonal, knowing that the cross product of two vectors being a 0 vector means that they're parallel, things of that sort. So know all the things around these guys, what they mean, how to actually do them, the formulas that govern them, but you don't need to know how to derive them. And you do need to know the distance formulas around them, I would say. Let's see, anything else? I think that's it. I mean, there are little things here or there, but you would ignore them anyway. So yeah, so let's stop there. Now let's talk about final exam practice problems. We have lots. Okay, so if you, I don't know. See here. This thing takes a long time to load. So I sent out an email about this, but just to make sure that everyone who is here knows about it. So what you're looking at here is class website, my class. Well, that's my page. So if you go CCNY Math Jhevon, just go to like people here and find my name. Those of you who are in my class should know how to find this already. Spring 2020 classes, click on either of these. I already opened them. So if you go here in the GH section, just because I copied it over in the RS2 section as well. Go through the GH section. If you scroll down, there is a section here called Final Exam Review, where I posted a bunch of problems where it links you to another page where you do the problems on that page through what files. So I link you to the old 212 page and tell you what to do out of the sample finals. I also give you a time limit. And I linked you to here. I believe this is the old 203 page. And this is maybe it's a 202 page. Right, but as you can see here, there are a bunch of problems that you can do, and I gave you some time limits for those guys. As well as other practice, if you go, you see the test 1 review, scroll down, there are both versions of the mock test for test 1. There is a mock test for test 2, those are posted. If you have, you can see the actual test 1 and test 2 that was given for the GH section. If you were in the GH section, what you can do is you can go to the RS2 section and you can do the actual test 1 and test 2 for that class, because they were different, similar but different, of course, because one was 24 hours after the other one, so I'm not going to give the same exam. But you can go through the old test. That being said, and I mentioned this before, my test would be slightly more difficult than I don't know if I want to say I'm the most comprehensive, most involved, or hardest, or anything like that. But it is going to, if you can get through my test, then you are fine. Like you can decimate the final. So that's one thing. Right? Yes, that's a guarantee. Get through means get them correct, right? So if you go through my tests and you're getting them right and you feel comfortable, then you have nothing to worry about. Like you are over prepared, right? So I saw the exams of the course supervisor, and my exams are harder than the ones that he wrote for his class. And I kind of over prepare you guys. I ask you harder questions. So really the final, if you're in my class, it should be a step down. So it's really an opportunity for you guys. So I know some of you are kind of nervous about the whole 65% thing, but honestly, it's kind of a blessing in disguise, depending on how you look at it. Because if you were surviving in my class, like you're getting like, if you were like a C+ average, I seriously think you can be an A- or an A on this final. Like it should, if you are struggling in my class, but you're still passing, doing decently, you should still be ahead of the curve here. So, so I just want to know that I just want you to know that I wouldn't really worry about the final as long as you do the practice. Now, something else to talk about. There are lots. Now, if you applied the study strategy I mentioned earlier in the semester with integrals, you can do the phantom study strategy on these. So remember when I spoke about how you were to study integrals, and I told you guys you can do this with anything. Now, if you actually put this into practice earlier in the semester, when I was talking about this back in February, you now have like a studying superpower. You can now do more studying in 5 minutes than the average student can do in 1 hour, right? Straight up, like, and I seriously mean that, right? So when you go to the final exam practice problems and you see me give you a time limit of 1 hour and 45 minutes to go through this problem set right here. If you practice the way I told you to practice, you could do that thing in 5 to 10 minutes or less, right? Because you'll never have to actually write anything out. You'll know how to actually go through the problems in your head and not end up and actually making that a quality study session. However, if you have not been practicing that, don't do this. Study just like everyone else, because it's going to end up shooting you in the foot. What happens is oftentimes students misunderstand how much they actually know. And so they'll look at a problem and they'll say, oh yeah, I could do that. But really, if you actually ask them, give them a piece of pen and paper and ask them to do it, they can't actually do it. The only way to know that you can do these things is if you are putting in the strategies that I mentioned earlier in the semester, right? So once you had put those strategies in place, you would actually be able to look at a problem and you can know that you can do it without actually doing it, right? And if you go through a bunch of problems like that, you can get through all that stuff that I mentioned here on my class. On the final review problem sets, you can get through all of those in like 5 to 10 minutes easily, right? And it will be as if you sat down for 1 hour each and actually did everything out, okay? But that's of course only if you're implementing the strategy from early on in the semester. At this point, you can't cheat the time. That's one thing I just want to get across to you. So if I told you about a strategy that required an initial investment of time so that you can study more efficiently in the future, you can't just skip ahead and start studying more efficiently in the future if you didn't put in that initial time investment. It's not going to work out. And then you're going to end up blaming me because I told you to do this study strategy and it didn't work. Oh, Jhevon told me to do this, it didn't work. Well, I told you how to get it to work. So if you haven't been applying that now, don't start applying that now. You just have to put in the time. Maybe what you can do is spend the first 3 days really going through things in the traditional way, writing everything out, making sure you're getting everything right, checking your answers on Wolfram Alpha or Symbolab and all that good stuff. And then the last day or so, you can practice a lot of problems in the other way. But other than that, I wouldn't really do it. Okay, so there's a lot of problems to get through. Now, in theory, you could get through them if you obeyed all my time limits, but it's going to be a lot of work. So for those of you who have been fall behind and you want this, people have been asking me for extra credit and stuff, think of this as your penance, going through all these problems and trying to get them done. If you can get through these, then again, the final exam is going to be a joke in my estimation. Based on what I'm hearing, based on everything, I don't see how you could really make the exam much harder than a paper exam. Like you're going to lose something, especially when it comes to like sketching and things of that sort. Yes, the time for the test is 2 hours and 15 minutes. And you can do 25 problems and you're going to do 25 problems in that time. So that is, again, something that I want to mention. So what that works out to, that's about 5.4 minutes per problem, okay? So most of you should be aiming for like maximum 5 minutes per problem to make sure you don't run out of time and all that good stuff. And of course, if you have accommodations, then you can scale that by time and a half or whatever. So if you're getting time and a half, you should be taking like 7-ish minutes per problem. If you're getting double time, you should be taking like 10 minutes per problem. but that's the range. You should be spending about 5 minutes per problem, no more. Yes, and you should be getting through problems a lot quicker than that if you've been paying attention to how we've been doing things, because we've really been going to town. Okay, so now maybe we can get to some problems, calls for discussion. I tried to set up a poll. I don't know how that, I don't even know if I'm going to use that here, but we'll kind of go with the flow here. So in the remaining time, I just want to go through a bunch of problems. Hopefully it will spark some discussion, jog your memory on how to do certain things, and we might jump around and all that sort of stuff. For some of you, if you are in the RS2 section and also in the ST section, some of this might be repetitive, but I don't necessarily think that's a bad thing. Because with the GH section, I didn't cover any of these kind of multiple choice quick problems. So I do want to go over some of them that I went through with the other classes, and we'll start there. But then we'll eventually get into new problems, which I didn't do with any class so far. So let's actually just do that. Unless at this point, if you have any questions about yes. So someone is asking, so if you're in the exam and you have problems, your first go-to should be Blackboard Collaborate Ultra. I will have a room set up that you can go to, and I will be there to answer your questions. I sent out a Zoom link, but that's only as a backup. Because there is a percentage of the faculty population which have no luck with Blackboard, myself included. So if anything is wrong and Blackboard Collaboration Ultra is giving me trouble, I will also have that Zoom room open so that you guys can find me. So that's what I mentioned earlier. Some people were trickling in even just a few minutes ago, so I'll just quickly mention that again. Yeah, so there is no proctoring in the traditional sense. You just log into Blackboard, you do the exam as I showed you guys. If you have questions or an issue with the exam and you need to reach me, if you have a question or a problem only, then log into Blackboard Collaborate Ultra, try to find me. You would have been logged into Blackboard already, so you just go to the new, open a new tab, go to the Collaboration Ultra section. If for some reason that's out of commission, I will have a Zoom link that you can reach me by there. It's just to have a central location where I know that people will come here for questions. If you don't have any questions, then you'll never have to see me during that day. Okay, so we went over that. So it's 25 problems, 4 points each. You should be spending around 5 minutes per problem. My class, you guys are over prepared. You should ignore these things. And for those of you who were practicing some of my study strategies, you can actually study for this final in under 2 hours and just get an A and then go home. Yes, for my class, I'll have you guys upload your work. And I'll send you guys instructions on that. Okay, now let's actually practice some problems, I think. That's why we're all here. And that being said, where did I put these guys? Maybe over to the side. Boom. 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 So some of you would have seen some of these guys before. and that's fine. We can quickly run through them. This is just to wet our beaks. Maybe after that, I might even skip ahead and then jump back, jump around. Okay, so let's start from the beginning. Okay, so here, these first few problems are true or false. Let's try to get through these guys in like, I don't know, 10 minutes or something. 10 or 15 minutes to get through these. All right, so you guys are gonna go with me. Just as soon as the answer comes to you, shout it out in the comment section or maybe audibly, and then we can move on. I will maybe launch some polls when we get to later questions, just to have you guys follow along a little bit more, and I can see where the majority of people are and how they feel on certain topics. Okay, problem one here, true or false. So these first few problems, true or false, just to get the brain juices flowing. Go. So I guess especially the GH class, you're going to want to chime in here because you guys probably haven't seen these. All right, so we have a false. This, the first one, is true. All right. Did you actually sketch it out, or are you just guessing? So, okay, so remember r theta would look like this. Here's a theta, that's a distance r. Negative r would mean you go the other way, right? So if this would be minus r theta, but then if you add pi to that, it brings you around here. This is plus an angle pi. It brings you around here. So your r comma theta is the same as your minus r comma theta plus pi, or any multiple of pi. So in general, r comma theta is equivalent to r comma theta plus 2n pi for any integer n, and it's equivalent to minus r comma theta plus n pi for any integer n, for any odd integer n. Okay? So yeah, so that's true. This is the graph of a straight line, true or false? Yes, good you remember that now, Kevin. It's better you remember it now than you forget it on the final. That's why we're doing it. Okay, so this is actually true, right? What's that equation? It's x equals 5. Remember, x is equal to r cosine theta. This is a circle, true or false? That is true. Okay, how do we know that that's a circle? Well, if you have r equals cosine theta, you can multiply both sides by r. This is x squared plus y squared equals x. So this is x squared minus x plus y squared equals 0, or it's x minus a half squared plus y squared equals a half squared. So that's actually a circle just by applying the polar coordinates equations. So this guy, not in our syllabus, so we can ignore it. True or false? This is a hyperbola. False. 6, this is a hyperbola. True. Right, of course, to put it in standard form, you would divide both sides by 16. So x squared over 4 squared minus y squared over 4 squared equals 1. These 3 points, if P, Q, and R are 3 points in space, then this equation holds. No, difference of squares is not always a hyperbola. So you do want to recall here. Oh, these are some other questions. hyperbola. They have a very special form, x minus a x minus h squared over a squared minus y minus k squared over b squared equals 1. You need to have a 1 on this side. And so just having just having a difference of squares is not a hyperbola. The problem was there was a 0 here. Now, if you look at P, Q, and R, if you look at P, Q, R, these points, you look at the vector PQ, and you look at the vector RQ, and then you look at the vector PR. So is it true that this one minus that one is this? So of course, minus RQ is going in the opposite way. And I mean, another way of thinking of this is that is PQ equal to PR plus RQ? That's another way. Is that equation true? Are you answering yes to the question or yes to something else? Okay. Okay, so what about this question? Is that true? So if we take PQ and then we subtract RQ, which means it looks like this, then this result here is going to be PR. Right, so that's false. Is QP this vector? So I have this coordinate and that coordinate. What about this? So remember, if we want to take QP, we do final minus initial. Right? So it's -1, -2, 2 minus a -3, and 1 minus a -1. So that's actually the negative. So this is false. The unit vector opposite direction to this vector here no, in the vector QP, P is the final. This is initial. Now for this one here, you'll notice that the magnitude of the vector x is actually 3. And so if you divide this vector by 3 or multiply it by a third, you would get a unit vector in the same direction. Now, if you multiply that by a negative number, you would get the unit vector in the opposite direction. So this one is actually true. A vector parallel to this line is this vector, true or false? Okay, tell me a vector that is parallel to this line. We're on problem 10 now. Want to speed this up and get to some more interesting problems. Tell me a vector that's parallel to this line. 2, 1, 1. Right. Now, is this vector parallel to that one? Right. No, because it's not a scalar multiple. Notice that if I had to get this first coordinate to be -1, I would have to multiply by -1/2. However, if I multiply the second coordinate by -1/2, I do not get this second coordinate. So that's actually false. Moving on. A normal vector for the plane is this. True or false? What is the normal vector here? But what's the normal? If I ask you, what is the normal vector for this plane? What would you tell me? Right, you tell me 1 minus 2, 1, right? The coefficient of x, y, and z gives you the normal vector. Now, what you'll notice is that that's parallel, right? If I multiply this by -2, I get this one. So the n that they mentioned here is a vector that is parallel to a normal vector. So yeah, it's also a normal vector, okay? So any vector that is parallel to a vector normal is itself also normal, right? So remember, vectors, their position doesn't really matter. And so any vector that's parallel to that direction is fine. Now, a trick question could be something like if they ask you for the unit normal, and then you'd want to make sure that the magnitude of the thing they're talking about is 1. But in general, that's not a requirement. Anything parallel can work. If I plus j plus k cross I, is that I plus j? That is false, because we know that k cross j is not, k cross j is minus I. And we know that from, where did we do that? Over here with the cross products. Right, we know that I cross j is k, j cross k is I, k cross I is j. We also know that I cross k is minus j, k cross j is minus I, j cross I is minus k. So we know all that's up. So k cross j is minus I by doing that. So it's not 0 in particular. And so that's false. If u and v are vectors in 3 space, then u cross v is equal to v cross u. True or false? False. In fact, u cross v is equal to the negative of v cross u in general. If u and v are vectors in 3 space, then the magnitude of u cross v is equal to the magnitude of v cross u. Well, that's true, right? They will both have the magnitude that is equal to the area of the parallelogram formed by the vectors u and v. Okay, u and v are vectors in 3 space. V dot u cross v is equal to 0. True or false? It is true. Yes. Now that you know the answer, can you see why? No, that's not the scalar triple product. But look at it. You have a dot product, right? You have something dot something. Right. So how does U cross V relate to V? If you had to use a phrase to describe how these two vectors relate to each other, what would it be? No. It's one word. It's one of the buzzwords. They're orthogonal. The cross product is a vector that's orthogonal to the two vectors in the product. So U cross V is orthogonal to both U and V. And so now the question is, if you take V and you dot it with something that's orthogonal to V, what is going to be the result? It's always going to be 0. That shouldn't be 0 question mark, it's 0. U dot V is 0 when they're orthogonal. That is another thing that we learned from this lecture up here, the cross product lecture. So in this double highlighted box right here in the cross product lecture, something that you need to know. Okay, A and B are orthogonal if and only if A dot B is the 0 scalar. A and B are parallel if A is a scalar multiple of B. A and B are also parallel if A cross B is the 0 vector. And A and B are parallel if A cross B, the magnitude of that is the 0 scalar. So these are all things that you should know automatically, right? That's something that someone could test you on easily in a multiple choice problem. So yeah, that's actually true. 16, this is equal to that, true or false? That's actually true. Because U cross V is the negative of V cross U, so those turn around, and scalars can factor out, right? You can factor scalars in and out of these vector, out of the vector and the dot product. You learned that. I cross K is J. Right, so again, you can go back to that circle thing. I actually forgot what they asked us about. I cross K. So if you do I cross K, you get negative J. So that's false. If a vector y is a scalar multiple of a vector x, then x cross y is the 0 vector, right? That's a bolded 0. True or false? Right, based on the 4 rules I just told you, that's true. Scalar multiple means it's parallel. And if you have two vectors that are parallel, the cross product is the 0 vector. Another way you can know this is, remember, the magnitude of the cross product of x and y is the magnitude of x times the magnitude of y times the sine of theta, where theta is the angle between them. And that's how you can know that parallel vectors will have a 0 vector cross product. Okay, so these guys are x and y are vectors in 3 space, then x cross y plus y cross x is the 0 vector. True or false? It's true, because we know that you know what? I'm thinking, Kevin, you should always answer the opposite of what you're thinking. I don't know. Like, if you're in a multiple choice and you have like choices A through E, like what's the opposite of one of these letters? I don't even know. Like, if you think the answer is B, what would be the opposite? Yeah. Don't worry, Kevin, brush it off. Come on, get back into the game. cross product of two unit vectors. That's right. I like to see the camaraderie here. Cross product of two unit vectors is a unit vector. Think about it. If I take two unit vectors and I find the cross product, is it always a unit vector that results? Give you guys 10 more seconds on this. You have an answer, David? What do you think? So David thinks it's true. And I don't know. At this point, I think David's maybe trying to keep Kevin company because it's false. Remember what we said, right? Yeah, like sheer probability, you had to get something wrong eventually. Remember what we said. If we cross product two parallel vectors, the result is 0. So what if I made both unit vectors parallel to each other? The cross product is going to be 0, right? The 0 vector. It's not going to be a unit vector. So as a counterexample, if I take I cross I would get 0, which is not a unit vector. Okay, slight variation on problem 20. The cross product of two perpendicular unit vectors, is that always a unit vector? Now, I told you guys something earlier that can help you figure this one out. What if they're perpendicular? I cross I is parallel to each other. Orthogonal. We'll correct. I didn't write these. We'll say orthogonal. Like we're trying to be civilized here. Yes. Now stop stalling. What's the answer? You're thinking it's true because the last one was false. Like, what if you didn't even see that? Tell me why that's true. Okay, let me ask this question. What is the magnitude of a cross product? So remember, the magnitude of a cross product is going to be the area of the parallelogram formed by the two vectors. Now, if your two vectors are perpendicular, then the parallelogram they form is going to be a square. Now, if both vectors form a square and they each have length 1, what is going to be the area of that square? It's going to be 1. So the magnitude of the cross product is going to have an area of 1, right? Which means it's a unit vector. So this is true. All right, set of points, x comma y comma z, such that x squared plus y squared equals 1. Is that a circle? Right, false. That is a cylinder. All right, Kevin's back in the game. All right, set of points, x comma y, such that x squared plus y squared equals 1. Is that a circle? True, right? And so, I mean, these are the kinds of things that you'd have to look out for on a multiple choice test. It's not that you guys don't know what things are, but just a slight wording. The fact that they put a Z here versus not having a Z, it makes a difference, you know? And one way you can be right, you have the right answer in one context, but you're not paying attention quite to the context that you're in. That's kind of where you'd have to look out for. But as long as you're paying attention to the context that you're in, you guys are over prepared for the exam. So just going through these problems, that's what I really want to elicit in you guys. The idea of reading very carefully, fully understanding the context you're in, and then remember your training grasshoppers, you'll be fine after that. All right, this lies on that quadratic surface. I mean, hopefully you know how to check that. You just plug in this for X, this for Y, this for Z. I mean, you'd plug that in. 2 squared minus 3 times y squared minus 9 times z squared. And that's not going to be 1. Right? That's going to be something else. So that's false. Is this an elliptic paraboloid? False. Right. So remember, for elliptic paraboloid, one of the guys has to not be squared, and the other two squares have to have the same sign, right? So you'd have to have like a z equals x squared plus y squared or something in that form, right? The fact that you have these two negatives here is a problem. In fact, this guy here is like a hyperboloid of 2 sheets or something like that. All right, so 2 lines, these guys here intersect at 1 point. I mean, that'll take a long time to check, but hopefully you guys know how to check it. So let's move on. The line and the plane intersect at 1 point. Now this can take a long time to check if you don't see some, right, so looking for the t when you plug everything in, that's kind of the straightforward way to do it. There's a nicer way though. Yeah, for the previous one, first of all, what I would do is I would change the variable. So for one, like use s, change all of these to s's, and then set up the system of equations. So you'd set up t minus 1 equals 5s plus 9. You'd set up minus 2t plus 1 equals minus 3s minus 5. And you'd set up 4t equals s plus 2. And you see, is there a solution for t and s that solve the system? This one, though, if you look at this guy here, you can see that the direction vector for this is going to be 1, minus 3, 2. And you'll notice that it is not parallel to the plane. It says intersect at 1 point. So wait, this here is the normal vector is 1, 1, 1. So this guy is parallel to the plane, which means there are only 2 situations. It will either intersect at all points along the line, because if the line is parallel to the plane and it meets it at 1 point, it will meet it at all points, right? Because the line will literally run inside the plane. However, if the line does not intersect the plane at 1 point, then it's never going to intersect the plane because they're parallel. So either way, the answer is going to be false. So you can actually know just by looking at the vectors, this is parallel to the plane. How do I know it's parallel to the plane? Let me ask you that question. So I just said that everyone's like, okay, Jhevon says it's parallel to the plane. I guess that's, what if I made a mistake? How do you know that would be parallel to that plane? Think about it. How can you tell if some vector is parallel to a plane or not? It's in the box of 4 rules. Right, Jesse got it. The scalar product is 0. Scalar product is another name for dot product. If I take the dot product of 1 comma minus 3 comma 2, and I dot product that with the normal vector, 1 comma 1 comma 1, I get 0. Dot product of 0 means that the v and the n are orthogonal. But if you're orthogonal to the normal vector, it means you're parallel to the plane, right? You meet at 90 degrees to something that meets at 90 degrees to the plane. It means you're parallel to the plane. Right? So that's how I knew these guys were parallel. And once they're parallel, it either intersects at all points or intersects at no point. And so that I can answer the question without actually doing any calculations. Two lines in 3 space don't intersect, then they must be parallel. True or false? That is false. We know that there's a third option in 3 space. They can be skew. Okay, I have 2 planes, P1 and P2. Normal vectors n1 and n2 respectively. If n1 and n2 are not parallel, then the intersection of this is the cross parallel direction vector. Yes, fancy P1 and P2. Answer the question. It is true. In fact, if you go back to the mock test 1, where we actually looked for the line of intersection of 2 planes, this, what was described in problem 29, is the exact strategy we use to find the direction vector for the line of intersection. We actually cross product the 2 normal vectors. Okay, if u cross v equals the 0 vector, then u must be the 0 vector or v must be the 0 vector. False. We saw an example earlier as well. I cross I was the 0 vector. Okay, if u dot v equals 0 and u cross v is the 0 vector, then u must be 0 or v must be 0. And that one is true. Notice what they just described. They just described 2 vectors that are orthogonal and at the same time they are parallel, right? Dot product equals 0 means that they are orthogonal. Cross product equal to 0 vector means that they are parallel. How can you be orthogonal and parallel at the same time to something? Well, either you or the thing has to be the 0 vector. The 0 vector is the only kind of thing that can be parallel and perpendicular to the same, to a non-zero vector at the same time. So, all right, so those are true or false. We're going to move into some longer form multiple choice problems. We're going to have choices A, B, C, some with A, B, C, D, E, some with even more choices. Let's jump into it. Integral of the form that 0 to infinity f of x dx cannot have a finite value, may or may not have a finite value, always has a finite value. B. May or may not, right? It can converge or diverge. And in fact, you might need paper for some of them, not a lot of paper. Right? If it could never have a finite value, we'd be in trouble because a lot of engineering is based on an integral of that form, like the Laplace transform. And we have a lot of integral transforms that are from 0 to infinity of some function. So yeah, if that could never work out, we would be in trouble. Evaluate this improper integral. Now here, I will say there's a typo, because otherwise it's not really a Calc 2 question. So I believe that should be a 3x, not a 3t. So this here would diverges if 3t by partial integration. But of course, that's not a topic that was covered. So, because with respect to x, Your function of t would be a constant. So this would be e to the minus 3t times x between 1 and infinity, which is obviously going to be infinity minus e to the minus 3t, which diverges. Versus if you have an x here, now you can actually do that integral. This will be minus e to the minus 3x over 3 between 1 and infinity. If you plug in infinity, you get 0 plus a third e to the minus 3. So it looks like this guy. So this also has the threat of catching you if you didn't apply the fundamental theorem of calculus correctly. You might have a negative sign in front of here, so you would look out for that. This is for those students who take the derivatives instead of taking the integral. They would get catched by A. All right, let's jump into some other problems. Here is one with a graph. Oh, we had another one over there. Let's do this. All right, match the graph with the equation below. Answer. Quickly. It is A. How do we know it's A? Because z equals 1 minus the square root of x squared minus y squared is a cone. The others are not a cone. This guy here is a plane. This guy here is a paraboloid. This guy here is something else. This guy, we didn't have a name for it, but notice that it blows up at the origin. When your x and y go to 0, it divides by 0. This guy z is equal to 1 over x squared plus y squared. So that's not really an object we have a name for. No, yeah, I didn't put anything like that on a bonus. It's not something that we have a name for, but you can tell that once you get close to the origin, you're going to actually shoot up to infinity. So it wouldn't stop at a point right here. It would actually just keep going up. The graph of this has an x-intercept of which of these? Right, if you plug in y equals 0, plug in z equals 0, solve for x. You get x equals 18 over 2, which is 9. And of course, the other two are 0. Moving on. How many units above the xy plane is this coordinate? 11. Right, the z coordinate tells you how far above the xy plane you are. Given the graph of this function y equals a constant, we will obtain a curve sliced parallel to which plane? Set y equals to a constant. You obtain a level curve parallel to which plane? Right, the xz. Kevin answering correctly with confidence. Didn't even put a question mark. Okay, let's keep going. Okay, partial of this. So if you take the first partial with respect to y, you would get what? We have some descent here. Something it's b, something is d. First partial with respect to y, you would leave the x, differentiate the ln of y. Then you would differentiate the y, leave the e to the x. Then you take the second partial with respect to y. This will give you minus x over y squared, because you think of this as y to the minus 1, and the e to the x will go away. So that is it. We have b. Here, is this function continuous at the origin? 0, 0, 0. True. Kevin's getting it again. How do we know? Because the limit as something approaches 0 of sine of that thing over the thing equals 1. And so what we have here is that the limit as x, y, z approaches 0 is of f of x, y, z is actually equal to the value of the function at 0, 0, 0. So this means continuous at 0, 0, 0. Otherwise, we're fine. Okay. Let's do these. So not multiple choice, but they came up. I don't actually remember what class they came up in at this point. So I just want to remind you guys about this guy, just in case implicit differentiation comes up. So remember, with implicit differentiation, this is when your dependent and independent variables mixed up. Dependent and independent variables mixed, right? So you don't just have z equals a function of x and y or anything like that. You have your x, y's, and z's mixed up, and then you want to find the partial. Then one, you bring everyone to one side. Right? Call this side big F. Right? So that means, right, everybody on one side call him big F, set equal to 0. Right? So that's the first step. Second step, now find indicated derivative. By now this definitely wasn't covered, but this is going to be in the next section of your textbook, but it's quick enough for me to tell you a formula. So it's the negative reciprocal of partials. So for example, if you wanted to find the partial of y with respect to x, it's the negative, I take the partial of x divided by the partial of y. Or if I wanted to find the partial of z with respect to y, this is the negative partial of y over partial of z. Or if I wanted to find the partial of x with respect to y, this is the negative partial of y over partial of x, etc. Okay, so you can actually, so that's a strategy that you can use with implicit differentiation. You can use that formula. So let's quickly knock those out just to make sure that we're solid on this. So if you want to find the partial of z with respect to x at the point 1, 1, 1, and your x's and z's and y's are all mixed up together, Make sure everyone is moved to one side, which in this case it already is. So I'm going to think of this as my big F. And so my partial of Z with respect to X is going to be equal to minus partial of X over partial of Z. So it's going to be minus, I'm going to take the partial with respect to X. So that's Y plus Z cubed over partial with respect to Z. So I would get 3Z squared X minus 2Y. Now, of course, if I want to evaluate this at 1, 1, 1, I'm going to evaluate this at 1, 1, 1. And so this would give us minus 2, looks like. Okay, so when you want partial Z, partial X, you put the partial of that big function of with respect to X on top, put the partial with respect to Z on the bottom, and then take the negative. And this is a quick way to do implicit differentiation. And yes, this is the Calc 3 trick I taught you guys. There's a longer way to go through it, kind of the way that you would do implicit differentiation as learned in Calc 1. And this move, by the way, would actually work in the Calc 1 setting. When they gave you implicit differentiation problems in Calc 1, you could have taken the partial with respect to X, divide by the partial with respect to Y, and then take the negative, and that would actually be the answer using implicit differentiation. So it's actually a lot quicker. So just in case those show up. So what you can do now, you realize that you can do a lot of these guys very quickly. So whenever you have this situation, you know how to find the derivatives very quickly. So here, your partial Y with respect to X, this is minus Fx over Fy. So this would be minus, take the partial with respect to X. Of course, I would move this guy over. So it becomes negative ln of X. And then I take the partial with respect to X. So I'm going to get 2xy plus yz minus 2y cubed minus 1 over x. Then divide all of that. The negative sign stays on the outside. Divide all that by the partial with respect to y, which is going to look like x squared plus xz minus 6xy squared. And that's going to be your answer here. And if I see about partial of x with respect to z, that's going to be minus partial of z divided by partial of x. Partial of x we already computed, 2xy plus yz minus 2y cubed minus 1 over x. And on top, put the partial with respect to z, which is xy, just xy. And that would be that one. And if I see what was the partial of x with respect to y, well, that's going to be minus fy over fx. So that is going to be x squared plus xz minus 6xy squared over 2xy plus yz minus 2y cubed minus 1 over x. And that's that. If you were in someone else's class, they'd probably penalize you. Like I wouldn't penalize you for using a Calc 3 technique in a Calc 1 class. Now distances, this is another one. I think, was that all the problems I had right here? This is another one that I wanted to go through quickly with you guys, just so that you know how to do it if it comes up. I'm not completely sure something like this would come up, but you have 25 problems. So Just want to cover all our bases, just in case they ask you about distances. These are applications of the dot and the cross product. So if you want to find the distance from a point to a plane, so remember the idea that we used here. So this is going to use a dot product, right? So we have 1, 2, 1 here, and we have our plane here. We know that the normal vector, this is n equals 1, 1, 1. And what you do is you find a random point in the plane and connect it to the point here, call that vector b. And you can find a random point in the plane by just finding 3 numbers that satisfy this equation. So for example, 1, 0, 0. Any point in the plane. So any point in the plane. Then what you want to do is scalar project b onto n. So project the shadow of b onto n. And that's actually going to give you the distance. So your distance equals, and we take the magnitude because this could give you a negative, the scalar projection of b onto n. So this is going to be n dot product with b divided by magnitude of n. So in this case, you would have the magnitude of 1, 1, 1 dot product with b, which is going to be 0, 2, 1 over radical 3. So that's going to be 3 over radical 3. Come again? Scalar projection? Yes, I found the vector b. Remember the final minus initial idea? So I took 1, 2, 1 minus 1, 0, 0. That is the vector b. And I throw it in this formula here. So this is something, this is one of the applications that came up after at the end of the equations of lines and planes. So here it is. And with a difference distance between a point and a line, that also came up at the end of that section. So that would be how you do that. That's the distance from a point to a plane. So just in case a problem like that shows up on the final, we have a lot more problems here. Distance from a point to a line. This is an application of yes, I'll post it on YouTube, of course, at some point tonight. So if you have to leave at 6, I guess you can go. Stick around if you can. I'll stay by a little after 6, but if you have to go, you can go, I guess. So here's our line, which we know a vector in the direction of the line, right? So this is the vector v. It is -1, -1, 1. And here's our point that is some point away from the line, 1, 2, 1. And we're going to do the same thing. Pick a random point on the line and connect it to this point over here, call it b again. And what we want to do is we want to measure the distance here. But if I imagine that this here is theta, that's a right triangle, d is actually going to be the magnitude of b sine theta. And so what you'll realize here is that you'd have your d is equal to the magnitude of b sine theta, which we can multiply and divide by the magnitude of v. And why would we do that? Well, because this guy here is the formula for the magnitude of the cross product. And that's going to be the magnitude of v cross b over the magnitude of v. And so here, what we would do is find a random point on this line. So I can plug in, say, t equals 0. That will give me the coordinate 2, comma, minus 1, comma, 3. And so I know that my my b would be say 1 minus 2 minus 1, 2 minus a minus 1, that's 3, 1 minus 3, that's minus 2. And I know that my v here is going to be minus 1, minus 1, 1. And then what I can do is I can just take the cross products of these guys, I, j, k. This implies b cross v is going to be equal to and we're going to take the magnitude of this. So that's 3 minus 2. Then this is minus 1 minus 2. And then this is 1 plus 3. We're going to divide that by the magnitude of v. And so that's the square root of, 26 divided by the square root of 3. So that's how you can find distances. Okay. Okay, so now I have a bunch of problems about series. I have some problems about polar coordinates. I have some problems about sequences, and I have some problems about integration. Okay, so the next thing I want to do, let's take a vote. Which topic do you feel least comfortable with in a multiple choice setting? You guys want to do some series problems, integration problems, polar coordinates, and parametric equation problems? Okay, let's do series and sequences. All right, let's do series. I'll be like this guy, this guy. All right, let's run through some of these. All right, AN is a conditionally convergent series. Which of the following is not necessarily true? Right? This, remember, that was the main difference between absolutely convergent and conditionally convergent series. Absolutely convergent series can change will never change their value. Conditionally convergent series can, if you rearrange the terms. You can get a conditionally convergent series converge to whatever real number you want, and you can get it to even diverge. Very strange, not good for calculus. Which of the following series converge? A converges. So I think this was either a trick question or typo, because there are actually two answers. This one also converges. Okay, moving down. Consider this series. The ratio test is applied to the series. Which of the following results implies the series is convergent? Ah, do you guys see a poll? Okay, do it. Who selected H? H isn't even on the thing. Come on, the poll is anonymous. Get your answers in. Oh, this is interesting. This is really cool. Only A through E are acceptable answers here. So I don't know who's choosing other things. There are some future problems that has more choices. That's why I have so many choices. Most people going with D. Okay, let's end polling. So D is the choice. Hey, that wasn't so bad. That was actually kind of cool. With a close second. Well, not close second. The next closest answer was A. But most people think D. Let's actually see. Now, remember what you would have done with the ratio test. You would look at the limit of an plus 1 over an plus over an is less than 1. That's what you would check to show convergence. So that means it would look like e to the n plus 1 over n plus 1 factorial. You set that in absolute value, take the limit, times, you go by the reciprocal, and you start simplifying. This would cancel into that. This cancels the factorial part. And so what you end up with is the limit of e over n plus 1, and getting less than 0 means convergent. And in fact, this is convergent because that goes to 0, which is always less than 1. So this actually converges absolutely. But the question, according to how we want to respond, is with D. Yeah. Interval of convergence of this guy. Another poll, go. Oh, C was in the lead, but B is currently taking, oh, C is back in the lead. Now, this one is neck and neck. A lot of people have differing opinions between B and C. Geez, there's one person with D. B and C, neck and neck. All right, let's stop there. It's been almost a minute and a half, which is way more time than we want to spend, right? Let all the other kids spend Oh, you like the poll thing? It is fun. And I'm kind of seeing where it happens. Now there's one person who chose D. That is the person who is correct. So most people are fighting over whether it was B or C. So here's one thing. Notice that in C, the 3 is included. What would have happened if you plugged in x equals 3 in the series? Right? You would actually end up with 1 to the n. That is the summation of 1. That diverges. Right? So you cannot include the 3. Similarly, if you plug in minus 3, it also diverges because you would get minus 1 to the n. Now, how do we know how to find the radius of convergence of this guy? Well, remember, this guy here, it should remind you of a series that you have memorized by heart. Remember, there are 4 series that you're supposed to memorize by heart. So one of them is root test is too long, especially in a multiple choice test. You don't want to have to go over it. But yeah, it is geometric. But the root test is, not the root test. It is geometric, but you should actually have this guy memorized. And so you know that that converges for x less than 1. So anytime you see something to the n, that thing in absolute value must be less than 1 for it to converge by the geometric series test. But this is something you should know by heart. So what that means is for you, x over 3 in absolute value should be less than 1, which means that your x in absolute value should be less than 3. And the endpoints are not going to work. So this means that your x is between 3 and minus 3. Now, of course, you could quickly plug in the endpoints in your head. Plug in x equals minus 3, see what happens. Plug in x equals 3, see what happens. You'll notice that both will diverge. So D is actually correct. So that one person who was standing by themselves, like Captain America versus the army of Thanos. I don't know why that picture came to mind, but whatever. One person chose D, that person was correct. Okay, moving on. Some of this. So this question right here. Some of the infinite geometric series. What analogy would have been better? With Thor? Okay, let's do the poll again. And at least it keeps us honest. You know, we don't spend too much time. Oh, answer already. People going in with C. The thing is, I hope the polling actually gets recorded so I can see what the results were, because I'm not saving any of these polling results. It would be nice if the polls were saved. So we had a lot of people jump in with C, one person with A. Let's actually just stop there. 90% are going with C and 10% going with A. All right, how would you know? Well, first of all, you have to figure out what your R value is. So you know that your A is 1 because it's geometric. Your R is the guy that you keep multiplying repeatedly by to get the new terms. So that's going to be 2/5. And you know that it converges to A over 1 minus R. So it's going to be 1 over 1 minus 2/5, which is 1 over 3/5, which is 5 over 3. So C, that is the geometric series. Okay, which of the following series converge? Sequences. Which of the following sequences converge? 5n over 2n minus 1. Relaunch another poll here. This is nice. I seem to get way more participation with the polls than I do with from the chat. So let's keep doing this. Okay, so a lot of people going with D here. So it's again between D and A. Five more seconds. Get your answer in. Okay, so we have 22%, 2 people going with A and 78% going with D. This guy here, that actually converges to 5/2. This guy here diverges. So that goes off to infinity, right? That's an exponential versus a polynomial. This guy here converges to 1. So it turns out that 1 and 3 converge, and that's D, right? So the masses had it there, okay? So one thing you need to remember that would help is logs are much smaller than polynomials, which are much smaller than exponentials, which are much smaller than factorials, which are much smaller than the variable exponentials, right? As n goes to infinity, right? So for the middle one, the top is an exponential, the bottom is a polynomial. The exponential is going to win, the numerator is going to overwhelm the denominator, so it's going to go off to infinity. This ratio of leading coefficients leads us to 5/2 is the answer. Here, a similar idea to ratio of leading coefficients will lead us to the fact that that converges to 1. No, convergence of sequences are completely different from convergence of series. When you talk about convergence of sequences, you're literally just taking the limit. It's a limit problem. So we're literally here looking at the limit as n approaches infinity of these guys. For a series, it's not true. For a series, in order for it to converge, the limit must be 0, but you're not guaranteed to converge if the limit is 0. But you know that if the limit is non-zero, then you would actually diverge. In fact, if I put series in front of all of these guys would have diverged. None of them would converge, right? Because none of them have the limits going to 0. We can use the test for divergence. Okay, this question. And the poll is relaunched. Give 30 seconds for this one, and that's more than enough time. Okay, polling ended. 10-1, A to B. So 91% people think A, 1% thinks B, and the answer is A. So that is A is actually the integral test. The integral test tells us that. We can look at this improper integrals and it will converge if and only if the series actually, the corresponding series converges. So that's the apply integral test here. And the statement is an if and only if, so if they swap the series with the integrals, the answer would still be true. Okay, this problem here. A series convergent if and only if this one's a little bit harder, but not really if you paid attention. It's not something that's stated in a test per se, but it's more stated in a definition. Okay, most people going with C, 73% go with C, 13% apiece going with A and B. C is the correct answer. The sequence of partial sums converges. So it's not just a sequence of terms. There's a counterexample to that. The harmonic series would show you that B is incorrect, right? Which of the following statements is true? Only one is true. Okay, we'll give about 10 more seconds on this one. Get your answers in. Okay, we're gonna wrap up now. All right, so A comes out the winner according to the polls with 31%. E is second with 23%. And we have an even tie between B, C, and D for 15%. The answer is D, ladies and gentlemen. And we're now officially, I think for the last couple of problems, we're officially in uncharted territory. I haven't done any of these problems with any of the classes yet. So we're now getting into some new problems here. It's exciting. Now, A, if B converges, it tells us nothing about AN. So if you thought A was the answer, you need to reread the comparison theorems and read them very carefully. Of course, if the limit of AN equals 0, it does not mean that the series is convergent. The series of 1 over n is a counterexample to this, the harmonic series. Now, C is kind of strange. So when I was looking at this, I actually skipped over C because the thing said there's only one correct. I just wanted to know the others are going to be easier to figure out than that one is. The sign of 1, who remembers what that is? Yes, I know it's less than 1, but I'm not going to really, you can actually know that as well. But I just saw that power and I immediately skipped over it because I figured I don't want to worry about what the value of sine of 1 is. Now, it's definitely less than or equal to 1, so you could actually know that that's going to diverge as well, but whatever. The second one, basically, that's the definition of being absolutely convergent. If you have a series that's convergent, then it means that it's absolutely convergent, given that all the terms are positive. And then therefore, if you make it alternating, it's definitely going to converge even faster. So yeah, D is clear there. Ratio test can be used to show that converges. So remember, the ratio and the root test, these are always going to be inconclusive for rational functions, for sequences, for series of rational functions. So that's something that you should know. So if you're in a test and you want to see, does the series converge or diverge, and it's a rational function, is the AN term, don't use the ratio test or the root test. They are always inconclusive for rational functions. So that automatically takes E out of the picture. So D here I saw is the answer. C, you can also say the answer right away, but my mind just automatically skipped over it. I didn't want to even bother. Moving down. Sn is the nth partial sum. Of this series. S1 is this, S2. Compute S50 minus S49. Okay, so I see what we can do here. What would that be? Da, da, da. Let me see. I know how to find the answer, but I have to actually do the calculations. So what did you guys get? Give 5 more seconds here. Okay, let's end. So we have 25% of people going with B, 38, which is the lead, going with C, 25 going with D, and 13% going with E. And that's quite remarkable. You're all wrong. So it's A. Like no one chose A. Okay, so what went wrong here? I think you guys are mixing up partial sums. So remember what partial sum is. When you say Sn, what that means is you're adding up the first n terms. So when you say S50, that just means you took A1 plus A2 plus A3 plus going all the way up to A50. And when you say S49, that means you take A1 plus A2 plus going all the way up to A49. Now, of course, if you subtract these, if you take S50 minus S49, what happens is, well, all of these guys that are in common are going to cancel out, and you would just be left over with A50. And so you just want to plug in 50 for n. So it's minus 1 to the 50 minus 1, 1 over 2 times 50 minus 1, minus 1 over 99. Okay. So don't make a mistake between the partial sum versus the sequence term. So that's normally considered called an by notation, and the partial sum is the sum of a bunch of ans. And to refer to an earlier problem, when they said a series converges means that its sequence of partial sums converge, it's talking about this guy. Right? So it's not good to know that the an converges to 0. That's meaningless. You want to know that Sn actually converges to a number, and that tells you that a series converges. So going back here, so this question right here, when it says sequence of partial sums, it was talking about this guy, the Sn. That's a sequence in its own right. If it converges, then the series converges. Boom, consider this series. Applying the comparison test with this leads to which conclusion? Launch the poll. Comparison test usually refers to direct comparison. They normally mention limit comparison, but I mean, you can consider both if you want. I mean, direct comparison seems like it can work here. All right, let's stop there at a minute. So we have one person believing that the test would be inconclusive, the other believing that it converges absolutely. So 9 people believe it converges absolutely. And that is correct, it converges absolutely, right? Because if this I call Bn, that I call An, then what we have here is the An would be less than or equal to the Bn. Because this guy here has a smaller denominator, so he gives a larger fraction, and he's geometric. So that guy converges absolutely, right? And we know it's absolute because these guys are always positive. The An terms are always positive. So any convergence is going to be absolute convergence. So it definitely converges by the comparison test. And because all the terms are positive, 4 to the n plus 6n minus 4 is always going to be a positive number for n goes 1 or bigger. So B. So I guess now we're seeing how the multiple choice problems can play tricks on you. This is what I want you guys to get used to. I don't want you to be able to like solve these really tough problems, but then some simple multiple choice problem throws you for a loop. Let's relaunch the poll here. The radius of convergence of that guy. This one is a little bit longer. I'll give you guys 3 minutes for this. So this is like a problem that you get 5 minutes for. I'm giving you guys 3. Go. Someone already chose C. I don't know if there's someone who's like, when in doubt, choose C. They always just choose C without even thinking about it. The numbers coming in. C is actually in the lead. Okay, we're 2 minutes in. The rest of you get your answers in. She's still in the lead by a far margin. All right, end polling. So most of you think it's C, 67%. B is next with 20% of people. 7% think it's D and E, both respectively. Let's actually see if it's C. So remember, when you're doing radius of convergence, you always ratio test, which means you're going to look at the limit of an plus 1 divided by an, which just means take the reciprocal. And you want to force that to be less than 1. This is going to cancel into that. This is going to cancel into that. And of course, we know that these guys are going to cancel each other out in the limit. They're going to go to 1. And so this is going to give you the limit of x over 10. Now, of course, that's going to be x over 10. And you set that less than 1. And so you get x in absolute value is less than 10. Now, obviously, now that means C is the correct answer. Okay. So I mean, that's a fair problem. If you have to do computationally, that's like something that would give you 5 minutes for, but you should be able to get through it a lot quicker than that. All right. This one, the series n squared plus 1 over n to the 4th plus 1 converges by ratio test, diverges by the integral test, converges by a limit comparison test, diverges by a limit comparison test, diverges because it has alternating sign. Give you guys maybe 10 more seconds for this. Okay, we'll stop there. Most people think it's C. Some people think it's B. Well, this guy is convergent, right? So if you ignore the plus ones, this guy behaves like 1 over n squared as n is going off to infinity. So we do expect it has some sort of convergence. How do you prove that though? Well, the limit comparison test with this will give you a limit of 1, which is greater than 0. We know that this guy converges because it's a convergent P series. So the other guy converges by a limit comparison test. This series, cosine to the pi n over n squared. Give you guys 10 more seconds for this one. Okay, stopped at the 30-second mark. Most people believe it's A. It is correct. It's A. At 46% with A, 23% with B, 8% with C, 15% with D, and 8% with E. A. It actually converges absolutely. Throw in absolute values around this guy, and then it would become 1 over n squared. It's less than or equal to that in absolute values. And so by comparison, I can show that this converges absolutely. So by comparison test. Okay. The series minus 1 to the n of e to the n over n squared diverges because so they told you it diverges. Five more seconds here. Okay, stopped. 60% with C. A, B, D, and E all have 10%. And the answer is actually E. So yes, if you take the limit, it goes off to infinity. If you try to find the limit using the ratio test, that would also go off to infinity. And so having all terms positive does not mean anything when it comes to convergence or divergence. So 2 has nothing to do with anything. 1 and 3 actually will tell you that that guy is divergent. Now, the first one you would notice on a test is problem 1, because that's the test for divergence, which you know that's always the first series test that you try to apply. Okay, what's the interval of convergence of this guy? Can give you guys a little bit longer here. Give you guys 30 more seconds. All right, 2-minute mark. So end polling here. 13% are going with A, B, or E, and so those guys are all tied. C, most people think it's C with 38% and 25% going with D. So I worked this out myself while you guys were doing it, and it's C. How do we know it's C? Well, interval convergence, always the ratio test. So I'm going to look at the limit of 3x plus 2 to the n plus 2 over n plus 1 to the 5 over 2 times n to the 5 over 2 over 3x plus 2 to the n plus 1. Now, of course, you start canceling out. These guys are going to behave the same as you go into the limit. The limit is going to go off to 1. This is going to cancel with all but that. So you are going to end up with the limit. Well, you're going to see there are no n's left over. So you're just going to end up with 3x plus 2 is less than 1. So that's what that's going to lead to. So you're going to have 3x plus 2 is less than 1 or minus 1, which gives you that your x is going to be, we don't know for sure that's less than or equal to. So you subtract 2, you get minus 1. Subtract 2 over here, you get minus 3. And then you divide by 3. So you get minus 1 and a third. Now you have to check each of these individually. Plug in x equals minus 1. If you get x equals minus 1, then your series looks like minus 1 to the n plus 1 over n to the 5 over 2, which is alternating, and that converges. If you plug in x equals minus a third, you would get the series of 1 over n to the 5 over 2, and that is a convergent p-series. So that also converges, right? And that's what you would go through in your head. You'd write this little scratch right here, and then you'll be able to conclude it. That. How are you guys doing? Do you want to keep going? Now, I know we're already outside the scheduled time. I'm willing to keep going if you guys are willing to keep going. So, and as I mentioned, I will be posting the video later. So if you absolutely must go, you can go. But it'll be good if you stick around and actually try. Right. Because if you can find out as much today about what you know versus what you don't know, then your next 3 days are going to be more productive, right? So you're not going to walk away thinking you know everything about series. If you're getting most of these problems wrong, you know, hey, series is something I have to look up for. Because series is definitely coming on the test. They're definitely going to ask you about things like whether a series converges or not, or what is the radius of convergence of a series. Things of that sort, they'll all come. So I mean, I'm willing to stick around. So you guys can, as long as there's a good number of people still here, I'll stick around. All right, let me give you guys, given that this on the interval of the, okay, maybe a minute for this one. Interesting. We're actually moving significantly slower with this problem than with the others. So I guess Taylor series is something you guys have to research, huh? Okay, the votes are coming in. $25 more seconds. Okay, so time is up. About 30 people have responded so far. Here's what I would like to know. If you know that you know how to find the answer, but you just needed more time, choose H. Like you know what you're gonna do, but you needed more time. I want to know who hasn't answered because they're completely lost versus, yeah, I could do it, but you're not giving me enough time. Some more votes coming in still. All right, we'll stop there at 4 minutes. So we have 14% thinking it's A, 43% thinking it's D, 29% thinking it's E, and we have one person believing that they could have done it if I had more time, just like Galois. So how would we do this? So what you need to remember is what a Taylor series would look like. Remember what a Taylor series looks like. The coefficient should look like f to the nth derivative evaluated at a divided by n factorial times x minus a to the n. Right? So that's what the Taylor series should look like. Right? So once you know that you want f to the fourth derivative evaluated at a over 4 factorial is going to be equal to, well, let me call this part here an. A evaluated at 4. Okay, so this means that my f to the fourth derivative at a is going to be equal to 4 factorial times a sub 4, right? And in fact, you can think of this in general. right? F to the nth derivative at the point is going to be equal to n factorial times a of the point. That's something that we actually derived why that's true. You don't really need to know why that's true, but you should know that what the Taylor formula would look like. And so now what you'll have is you'd have 4 factorial a to the 4th. This would look like 4 over 2 to the 4. So this is 4 factorial times, well, this is 2 to the 4th is 16, so this is a quarter. And so you would have pretty much 3 factorial, which is 6. The answer is B. Right? And no one chose B. And I think the problem was people forgot that factorial part. Some of you probably got the, well, a lot of people chose D. So a lot of you got this part here, right? That 1 over 4. Right. So the thing is you forgot about the n factorial. So remember, for the Taylor series, the coefficient is the nth derivative over n factorial, evaluated at the center point. Okay, so don't forget the n factorial. All right, moving on. Which of the following series converge? Yes. Wait, hold on. We just have like 2 more problems to finish up this section, I think. Stick around for these 2 problems. I don't think there are any more series problems left. Then I'll decide. So today we would have gotten through the review of series, and tomorrow we can do some other topics. Okay, 15 more seconds. Okay, so we'll end there. Most people think it's D with 40%, and then we have 30% each on B and C. So, all right, let's go through these. Okay, so this one here is an alternating harmonic. That converges. This guy here converges absolutely, because if I put absolute values around it, that's less than or equal to the series of 1 over n squared, so that converges. This one is a little harder to come by. However, if you just ignore all the lower ones, what you'll realize is that this is going to behave like the series of n squared over n to the 7 over 2. So this is going to look like the series of n to the 2 minus 7 over 2. And that's 4 over 2 minus 7 over 2, that's minus 3 over 2. So that also converges. That I can do like a limit comparison with the convergent P series. They all converge. What about this one? So this definitely converges because we only have these answer choices. So now the question is, to what does it converge? Launching the poll. So a lot of people thinking it's A, and 83% going with A, thinking it's converges to 0. And then we have the next set of people thinking it goes to D, 14%. We have more people going with A. I'll give you guys another 30 seconds on this one. Yeah, telescoping, I have to check. Did your textbook do telescoping in the... I have to check if that's something that I should tell you guys to ignore, because I don't think those are going to come up very often, but we'll see. I have to verify. Telescoping, note to self. All right, let's see what this is. So I didn't actually work out the answer here, but I kind of know how to find it. Maybe someone tell me, what did you think about to get to an answer? What do you see here? There is no common ratio, so it's not geometric. How do I know? Well, here notice that you have an n2 to the n factorial. It doesn't have a power. Common ratio is always going to be something to an nth power. So you'd have to have the whole thing raised to an nth power. Right? Another way, if you take the common ratio, if it's anything, it would be minus pi squared over 2 factorial. Now, if you take that and multiply it by itself, you do not get pi squared over 4 factorial. Right? Because the 2 factorial times 2 factorial is going to be 4. But 4 factorial is actually 24. So it's not a common ratio. So maybe someone else can tell me what the trick is here, what you should have noticed. Okay, now this one is cute. I didn't see this coming, but this is from one of the things that another series that you should have memorized. The cosine series was the trick. That's minus 1 to the n x to the 2n over 2n factorial. Remember that guy? So once I see something like that to a power 2n over 2n factorial, your mind should automatically gravitate towards a cosine, especially with a minus 1 to the n. So here what you'll notice is they plugged in x for pi. So your cosine of pi is going to be equal to the minus 1 to the n, pi to the 2n over 2n factorial, which is that guy right here. So that actually adds up to minus 1. Cosine of pi is minus 1. B is the answer. So be careful, it's not a common ratio. It just kind of, it's a common ratio in the numerator, but it's not a common ratio in the denominator. And yeah, so it's actually a cosine hidden. But again, when you memorize those, so remember, you need to remember, Winnie, remember. You need to be able to see these guys pop up in various forms. The series of x to the n, you should think of 1 over 1 minus x when you see that. That works if your x is less than 1 in absolute value. If you have the series of x to the n over n factorial, that is another way of writing e to the x. That works for all x. the series -1 to the n, x to the 2n over 2n factorial. See, anything that looks like that, where you can plug in anything in position of x, that is your cosine function. That also works for all x. If you see the series of -1 to the n of x to the 2n plus 1 over 2n plus 1 factorial, anything that looks like that, where you can plug in anything for the position of x, that is a sine. That also works for all x. The radius of convergence for all of these here is infinite, and the radius of convergence here has length 2. Yes, anything with a common ratio, the geometric series is the series with a common ratio. So a geometric series is the one that looks like a times r to the n, where a is a constant, right? And your r is a constant. So it has to look like something to an nth power. If it doesn't look like something to an nth power, it's not geometric for sure. So here, yes, the pi squared is to the nth power, but the denominator is not to an nth power. So the denominator breaks the pattern of the geometric series. And it seems like if you were to think of the geometric series as a possible answer, none of these choices would make sense with a geometric series. So if I was writing this problem, I would probably throw in some answers that look more like what the answer would have looked like if it were geometric. Just write down the answer, what it would look like if someone took r equals minus pi squared over 2 factorial, and write down what that answer would look like, because that would be a trick. Okay, that being said, here, so we're about to wrap up here. Just want to make sure I don't have more serious problems. So these are problems on polar coordinates. We'll work on that tomorrow. Polar coordinates. That's sequences, but I think we can do that tomorrow. This is parametric equations. This here is parametric equations and integration. Here was another series, but this is actually similar to a problem that we did before. So yeah, we'll wrap up there. But hopefully here you saw a lot of things that you need to review for the test. So we went through a bunch of things that you guys have to ignore because I literally over prepared you guys. So that's that stuff. We went through a bunch of true or false. So we did a lot of 3D stuff today. And we did some partial derivative stuff today, including implicit differentiation. And then we spent a lot of time on series. So we won't really do any series things tomorrow. We'll do some other things. Yeah, you have to go over it. I mean, you won't get true or false questions on the multiple choice. They'll average about 5 choices each problem. But yeah, the true or false can definitely get you to think a lot deeper. So go over these. I'll post a video and I'll post a PDF of this. I'll probably leave these guys off the PDF, the guys that we haven't done yet, and we'll go over those tomorrow. Maybe I'll throw in some other topics as well. But hopefully you're seeing where you might have gaps in your knowledge. So being able to compute things is one thing, but just knowing something good enough for a multiple choice problem, it's a different skill altogether. And it's easy to trick you. One little thing that's off and you can go from a situation where you're true to false versus like, look at 22 versus 23, look at problems 20 versus 21, right? There's just one word that's off between those two and it totally changed the meaning of the problem. So you're definitely going to have to be more careful of the context in which you find yourself. But we are going to wrap up there. We went definitely over time. But yeah, so we'll stop there. I'll catch you guys tomorrow and we'll go over some more topics and I'll post this guy here. Take care, everybody. That polling stuff was good. I'll do more of that tomorrow. It's kind of, I get more participation that way, so that's great. All right, I will see you guys in the next one. Take care, good luck, good studying. Remember to check out my problem sets on the math webpage. Give you some extra stuff. Yeah, same time tomorrow. And I will see you guys in the next one.